Hey guys, so now you know how to do the mathematical induction questions asking for what I would like to call just the easier type, right? Where it asks for divisibility by a certain number. Now we're going to look at those, and I'm sure you've seen it before, where they've got a lot more ends involved. So there's no divisibility question. It's prove something equals something else, and normally it's like on the left-hand side or the right-hand side, you've got a lot of pluses or minuses. All right, so it could be arithmetic or geometric series, and basically it asks you to prove some long-ass, addition equals some sort of summarized version. So here's an example, and although it doesn't look long, this thing stretches out. So just prove that equals that for n equals k. Now, obviously, you've got the same step one. So if you remember the step one from before, your step one is always prove true. So k is a positive integer. That's k is greater than or equal, or k is greater than or equal to 1. Okay. Alright, so step one, once again, it's prove true for n equals 1. Alright, so what do we have here? We have, now you have to understand that's going to be starting from r equals 1, ending at r equals 1. So in other words, that's just 4r plus 2, right? That thing equals 4 times 1 plus 2. Okay, so your summation, this tests your summation knowledge of that big symbol that looks like a funky E. Alright, and that's on the left hand side. Now the right hand side, you've got 2 times 1 squared plus 4 times 1. Alright, so this equals 6, and this equals 6. Left hand side equals right hand side, in other words. Therefore, true for n equal 1. Cool. Alright. Step 2 then. Step 2 again. Sorry. Step 2 was assume true for n equals k. Alright, now instead of writing this funky E, the summation sign, I'm gonna just spell it out for you a little bit. So like, not so much spelling, I guess I'm just gonna expand it out. That way it's just gonna be a lot clearer, right? So assume true for n equals k. So what that left hand side actually is, so you put 1 in first, okay? So if you put 1 in, that, as we know, it equals 6, right? So 6. And then summation plus, put 2 in, so it's 4 times 2 plus 2, which is going to be 10, right? Plus 3, plus, put 3 in, and it's 4 times 3 plus 2, which is 14. So obviously this is just an arithmetic series, right? And it goes up to 4k plus 2. So 6 plus 10 plus 14 plus 18 plus ... go all the way to the end, and it's plus your 4k plus 2. So what the question is asking is actually show this equals 2 to the k squared plus 4 times k. Okay? Now, since we've proved true for n equals 1, step 2 was assume true for n equals k. In other words, all that blah 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 plus 4k plus 2 equals 2k squared plus 4k is true. Okay, so we'll assume. Okay. Alright, so step 3 is where once again, where you're gonna earn your money. So step 3, you have to prove true. We are required to prove true. Required to prove true for n equals k plus 1. Alright, so now you're going to see a lot of these. As I said, induction is not very hard, okay? It's just a lot of, it's the same process over and over. It just depends on what kind of functions you're dealing with. Right now we're dealing with sequences and series. Before we really we were dealing with index laws. Rarely have I seen them ask trigonometric ones, and yeah, so I mean, and also they can, like, what they can do is, you know, they can spice it up a bit. Instead of your standard prove true for k is greater than or equal to 1, maybe they want to say for k is, you know, where k is bigger than 3 or something, right? So instead of starting at n equals 1, you're starting at n equals 3. Not only that, I've seen one where you're proving true for n is an odd integer, right? If it's an odd integer, you'd start at n equals 1, right? But then you wouldn't want to prove true for n equals k plus 1, because if you start at 1, k plus 1 is 2, right? And you're probably not going to end up proving true for that anyway. So for an odd integer, I'm going a bit off topic here, but before I begin, if they ask for an odd integer, which I have seen before, then you start with n equals 1, and you prove true for n equals k plus 2, right? In that case, k plus 2 would be 1 plus 2, the next one would be 1, 3, 5, 7. So it goes like that. So they're the only real variables that they can really shock you with in these sorts of questions, alright? So, continuing on this question. If we're required to prove true for n equals k plus 1, in plain English, what does that mean? In other words, we are required to prove that 6 plus 10 plus 14 plus 18 plus to the 4k plus 2 plus, and it's now you're gonna put in k plus 1, okay? So in other words, watch out here. Again, bracket it, always bracket it. 4k plus 1 plus 2. So yeah, I mean, the majority of the mistakes would come where kids just forget to put the brackets, right? And that will turn into 2k plus 1 all squared plus 4k plus 1. Okay, so we are required to prove that equals that, alright? So firstly, what I would start off with, first of all, is I'd make a side note here, and I would factorize this, because you've got k plus 1 on both sides, right? So that's actually k plus 1 times 2k plus 1 plus 4, okay? Or in other words, that is k plus 1, and that is 2k plus 2 plus 4, which is 2k plus 6. 2k plus 6. Or finally, that's just 2 outside of k plus 1, k plus 3. Alright, so that, I've just cleaned up the right hand side, alright? Alright, so what we're required to prove is, well, the right hand side equals that. We're going to now work on the left hand side. So left hand side equals, now always, as I said, you're always looking at your step 2, alright? So you're always looking up for your step 2, and we're going to get this out. So what we can do is see this bit from step 2. We're going to get rid of all that, because that bit is that bit here, and that's what you see in all these sorts of long ass and or yeah, the ones that have a lot of n's in the question, okay? That and that are interchangeable, so instead of rewriting this, I'm going to put this in its place. Left hand side now, if that equals 2k squared plus 4k plus, and that thing there expands out to 4k plus 4 plus 2. Okay? So all this stuff, you know, goes out to that, right? Which is going to be 2k squared plus 8k plus 6, which equals 2. K squared plus 4k plus 3. And if you know how to factorize, I hope you do by now. If not, you shouldn't be watching this video. K plus 1, k plus 3. Alright, so since I've already worked down my right hand side, what you could have done here is just write this right hand side equals. Okay? And here, therefore, that equals right hand side. Alright, and therefore true for n equals k plus 1. Alright, so once you do that, you know what to write for step 4. Exact same thing I wrote last time, if you haven't seen the one where I did all that blah blah blah. Okay, and that is pretty much the easy and the sort of more difficult, tougher ones that students find, types of questions that you will face. Good luck.